चलो, so we'll try to continue with the next topic of the gravitation beta, that is acceleration due to gravity and its variation. Okay, चलिए next heading लिख लिया बेटा, acceleration due to gravity. Acceleration due to gravity of the earth. Okay, if any body is kept on the surface of the earth, this is the earth of radius r और उसका mass capital F. If a small body is kept on this one which is having mass M, the relation between small g and capital G will be equal to how much for me? Small g will be equal to force divided by mass. Okay, so this will be equal to your capital G into your M divided by R square. So relation between small g and capital G is small g is equals to capital G capital M divided by R square. Okay, capital M is the mass of the earth, G is your acceleration due to gravity, capital R is the radius of the earth part. In terms of density, if I write beta, small g is equals to capital G, mass is equals to your volume into density divided by R square. That is equals to G, volume will be equal to 4 by 3 pi into your capital R cube into rho divided by R square. This R square and this cube will get cancelled. So this value will be equal to your 4 by 3 pi into capital G into R into rho. So this is the relation between small g and density. So small g is equals to 4 by 3 pi into G into R into rho. Acceleration due to gravity in terms of your density. Small g is equals to capital G 4 by 3 pi capital G capital R into your rho. Okay. Done better. Relation between small g and capital G is capital G capital M divided by R square. And relation between G and density is 4 by 3 pi rho G into your R part of relation. Done. Sure. Next heading. Acceleration due to gravity above the surface of the earth, above the surface of earth and below the surface of earth. Acceleration due to gravity above the surface of earth and below the surface of the earth. If I am talking about altitude, altitude means at a certain height. Okay, this is your earth. हाँ बोलो बेटा, am I audible? हैंड रेस कर रहे कोई 7075. चलो, now this is the radius, that is nothing but equal to r, radius of the earth. This is center, mass of the earth is capital M. ठीक है, यहाँ पर कहीं पर एक पार्टिकल है which is at a distance of, say for example, h from the surface of the earth. Done? Now acceleration due to gravity at a certain height, एक्चुअल फॉर्मूला जो है ना, g at a certain height will be equal to, याद है, कैपिटल G mass of the earth divided by radius of the earth plus of your h whole square. This is actual and standard formula. G at a certain height is capital G mass of the earth divided by radius of earth plus of your height into your square. Okay. If I'm talking in terms of your gravity due to height h and gravity on the surface of the earth, this value will be equal to Re divided by Re plus of your h whole square. Okay. When h is very small, when h is very small than r, then g at a certain height will be equal to g into 1 minus 2h divided by radius of earth. Okay, so these are the two standard formulas you need to remember. G at a certain height in terms of your Re plus h. If height is very small, g at a certain height is equals to g on the earth into 1 minus of 2h divided by r. Clear? Now see, if he is asking the decrease in the value of the g with height, what will be the answer for this one? Decrease in the value of g, in value of g with height h. So the decrease is given by the formula g minus g at a certain height. So that will come out for me 2 into g into h divided by radius of the earth delta g. So decrease in the value of the g with respect to height will be equal to, very important formula, delta g is equals to 2g into h divided by radius of your earth. Now if he is asking the percentage decrease, then how do you calculate it? Percentage decrease in value of g. Okay, so percentage decrease in the value of g, that is delta g, will be equal to g minus g at a certain height divided by g. Okay, because g on the ground is more, that is the reason I'm writing higher value minus lower value divided by g into your 100. So this will come out for me, delta g will be equal to 2h divided by radius of your earth into 100, directly shortcut formula. So percentage decrease you can calculate by the formula 2h divided by radius of your earth multiplied by your 100. That will give me the answer for. Clear? So these are the some of the standard formulas which should always be in your mind while doing the problems related to the acceleration due to gravity with respect to the altitude. Altitude means what? Height. Altitude is nothing but height. Clear? Sure. Next one. With respect to depth. With respect to depth. That means when a body is being taken to a certain depth from the surface of the earth. Okay. Let's see. From center to this one, this is the radius of the earth. Okay. Now I have taken a body from surface of the earth to a certain height, depth in this one, right? Okay. So here to here, this is your depth, that is nothing but d. Okay. So obviously this distance will be equal to how much, better? From here to here, that is the radius of the earth minus of your d. This will be the height. Clear? So then g value will be equal to, at a certain depth, g at a certain depth will be equal to how much? Or g in terms of your density. Use the formula g with respect to the density formula. You will get g at a depth will be equal to your g into 1 minus depth divided by radius of earth. I am not deriving it because these are the formulas which should be committed to your memory. So g at a depth will be equal to g into 1 minus of your d divided by radius of your earth. In terms of density, if he is asking, g at a depth will be equal to, use the formula of the density, 4 by 3 pi g into this distance will be radius of the earth minus of your d into your density. This will be the formula. Clear? Now see, at the center of the earth, at center of earth, d value will be equal to how much, better? At the center of the earth, d value will be equal to how much, better? Radius of the earth. Isn't it? So G at the center will be equal to how much for me? G at the center will come out for me 0. Am I clear? That means the weight of the body at the center of the earth is 0. So what is the weight of the body at the center of the earth? 0 weight of body at center of earth. At the center of earth is 0. Am I clear? If he's asking the percentage decrease in the value of G, percentage decrease in value of G. What will be the formula, beta? With respect to depth. With respect to depth. What will be the formula? G minus G at a depth divided by G on the ground multiplied by 100. So that will come out for me. G minus D, if I do it out, this will be directly D divided by radius of earth into 100. That will be the formula. Percentage decrease in G. This will be the formula. Am I clear? Sure. So just let me revise about the depth. G at the depth is equals to G into 1 minus D divided by radius of earth, and G at the center will be equal to how much for me? 0. And when the body is at the center of the earth, weight of the body at the center of the earth is how much for me? 0. Then if he is asking the percentage decrease of the value of the G with respect to D, the formula will be equal to how much for me? G minus GD divided by G into 100. Our percentage decrease in the value of the G is depth divided by radius of the earth multiplied by your 100. That will be the answer for. Am I clear? Sure. Tell me the answer for this question. The ratio between the values of acceleration due to gravity at a height 1 kilometer above earth, 1 kilometer above, and at a depth of 1 kilometer below the earth surface is how much? Can anyone tell me the answer? The ratio between the value of the G due to the height of 1 kilometer above and depth of your 1 kilometer below. I'll giving the options: R minus 2 divided by R minus 1. Second option is R divided by R minus 1. Third option is R minus 2 divided by R. And fourth option is 2R divided by R minus 1. Chalo, try to do and give me the answer. Anyone?
First option.
कौन सा आ रहा? R minus
First
2
option.
divided by R minus 1 आ रहा? Very good. First option is the answer for this one. You know both of the formulas, beta. G at your height is G into 1 minus 2H divided by R. And G at a depth also, you know the formula. G into 1 minus depth divided by radius. Is asking the ratio. GH divided by G at your depth. That is equals to 1 minus 2H divided by R divided by 1 minus D divided by R, because G and G anyhow will get cancelled. So this value will be equal to how much for me? R minus of 2H divided by R minus of D. Am I clear? H value is how much for me given in the problem? H is equals to 1 kilometer and the depth is also equal to 1 kilometer. So that will be equal to R minus 2 divided by R minus 1. Am I clear?
Yes, sir.
Sure. next Saturday. What is the effect of rotation? Effect of rotation of the earth. Effect of rotation of your earth. If earth has been rotating, due to its rotation, what will be the acceleration due to gravity at the poles and at your equators particulation? So I hope everyone remembered that formula. G due to the rotation, G dash will be equal to G minus radius of earth into its rotation omega square into cos square theta. Theta is your angle with respect to your horizontal. Okay, like say if this is your earth, this is your earth somewhere here, and this is your diameter in this direction in somewhere here. Due to its rotation here right now with an angular velocity. So when the particle is somewhere here, so this is your angle, this is your theta. There is a lot of derivations. I'm not bothering about the derivations right now there. So just remember, if it is making an angle with respect to your theta, so G dash will be equal to your G minus RE omega square cos square into your theta. Now it poles, what will be the answer beta? It poles theta value is equals to 0. So G at your poles will be equal to G on the surface of the earth. Am I clear? That is maximum. It is almost all unaffected from its rotation at poles. Okay. At equator, at equator, theta is equals to your pi by 2, 90 degrees. So G at your equator will be equal to G on the surface minus omega square into radius of earth. So obviously the value is decreasing. Value is decreasing. Lesser, small less. Approximately see if this is 9.83 meter per second square. This will come out for me 9.78 meter per second square. Very small difference, not much. That becomes minimum and maximum if it stops rotation. That we need to remember. If angular velocity is made more, then object may even fly off from the equator. And as we are moving from pole to equator, gravity decreases. That you need to remember. Done? So G actual formula is this much. Due to the rotation, G minus R into omega square into cos square theta. G due to the poles, same as that of your surface. G at equator lesser than your surface. Yeah, sure. Next one. Gravitational potential energy formula. Gravitational potential energy. Gravitational potential energy. Represented by letter U. Tell me, what will be the energy formula, beta? U is equals to minus capital G, mass of the earth, mass of the object divided by R. This will be the potential energy. U is equals to G m1 m2 divided by R. m1 is the mass of the earth, small m is the mass of the object divided by distance between them, where small r is greater than radius of the earth, beta. Small r is greater than of your radius of your earth. Done? That means r plus h it may be basically. And on the surface, can you tell me? On surface of earth, on surface of earth, potential energy will be equal to minus capital G mass of earth into m divided by, this will be radius of the earth on the surface of the earth. Done? Then at a height above the surface of the earth, at a height above the surface of earth, certain height, then U will be equal to, U at a certain height will be equal to minus capital G mass of earth into small m divided by R plus of your h, if h is countable. Then sure. One more and very important. Work done or change in gravitational potential energy. Work done or change in potential energy. Very important formula. Work done will be equal to delta U. Delta U is equals to U2 minus U1. That will be equal to capital G, mass of the earth, into small m, into this is 1 by R1 minus 1 by R2. Actually, it is 1 by R2 minus 1 by R1. I am removing the minus sign. That is the reason I am directly writing the formula. Change in potential energy is given by the formula capital G, mass of the earth, small m, mass of the object, into 1 by R1 minus 1 by R2. So this will be the work done in moving an object from one point to your another point. Clear?
Yes.
Now, this has been applicable only for the position outside the surface of the earth beta. Like say when the body is moved from surface of the earth, like say for example, in this condition, if R1 is equals to radius of earth and R2 is equals to infinity, then change in potential energy will be equal to how much for me? Capital G, mass of the earth, into m, into it is 1 by radius of earth minus 1 by infinity. That means this value will come out for me how much for me? Change in potential energy is equals to capital G, mass of our earth, small m, divided by radius of earth. Very, very important formula, isn't it? I can even write this one as small g is equals to capital G, capital M divided by RE square, isn't it? So potential energy can I write in terms of small g? Potential energy is equals to mg into your radius of your earth. That will be the answer. Change in potential energy. Clear? Now see here, in this case again, if R1 is equals to radius of earth and R2 is equals to certain height RE plus of your height h, then potential energy will be equal to how much? Delta U is equals to capital G, mass of earth, into small m, into 1 by radius of earth minus 1 by R2, that is RE plus of your h. If we simplify this one, we will be getting the potential energy formula. Delta U is equals to mg into h into R divided by R plus of your h. Very famous formula and very important formula, isn't it? Because as small g is equals to capital G, capital M divided by RE square. I am taking this approximation. So potential energy is equals to mg into h into R divided by R plus of your h, or mg into R into h divided by R plus h. Okay, if h is very, very small, if h is much, much lesser than radius of earth, then potential energy will be equal to mg into h. Okay, if h is much, much less, R and R will get cancelled. So potential energy is equals to mg into your h. Clear? Once again,
Yes, sir.
gravitational potential energy formula, U is equals to minus of your capital G m1 m2 divided by R. On surface of the earth, it is minus capital G m1 m2 divided by radius of earth. m1 is mass of the earth, m2 is the mass of the object. And at a certain height, U is equals to minus of your capital G mass of earth into small m divided by R plus of your h. Now, what is the work done here right now? Work done, very important. Work done or change in potential energy. Work done is equals to your U2 minus of your U1. So if I am simplifying that one, we are getting the formula as delta U is equals to capital G mass of earth, mass of the object, into 1 by R1 minus of 1 by R2. Now taking different cases here right now. If R1 is equals to RE and R2 is equals to infinity, then potential energy will be given by the formula delta U is equals to capital G m1 m2 divided by R, or delta U is equals to mg into your R. R is nothing but radius of the earth. Now second case, if R1 is equals to radius of earth and R2 is equals to radius of earth to a certain height, that means the body is taken to a certain height, then potential energy formula will be equal to delta U is equals to mg into h divided by mg into h into R divided by R plus h. And h is very, very small, delta U will be equal to your mg into your h. Am I clear? Now this one is something very important. Keep a star mark. At any point inside the earth, at any point inside the earth, at a distance, say for example x, at a distance of your x, where x is lesser than of your r. From where? From center of earth. From center of earth. potential energy will be? Potential energy anywhere inside will be equal to potential surface into mass. So potential formula minus capital G mass of earth small m divided by 2 times of radius of earth cube into 3 times of radius r e square minus of your x square. I told you this formula in potential due to solid. So U will be equal to your potential multiplied by mass. That is the formula what I am using. Okay. Now tell me what will be the gravitational potential energy when it is maximum where r is equals to infinity. Isn't r x is equals to your infinity. Now tell me if x is equals to 0, what will be the answer? If x is equals to 0, that means at the center of earth. At center of earth, what is the potential energy? Potential energy at the center of the earth will be equal to minus 3. This will be capital G, capital M into small m divided by, this will be 2 times of your radius of your earth. Isn't it? That means indirectly I can write it as potential at the center will be equal to 3 by 2 times of the potential on the surface. Okay, 3 by 2 times of the potential energy on the surface, not the electric potential, sorry, gravitational potential. Put a gravitational potential energy anywhere inside. This is your gravitational potential energy. Gravitational potential energy. Okay. So gravitational potential energy at the center is equals to 3 by 2 times of the gravitational potential energy on the surface. Am I clear?
Yes, sir.
चलो ये पूरे फॉर्मूलेस बाय हार्टेड है ना बेटा हाथ में. ओके चलो इसका आंसर दे लीजिए एक बार. Small application. When a body of mass m is moved from center of earth to the surface of earth, then what is the change in potential energy? Change in potential energy of the earth mass system is how much? When a body of mass m is moved from where? From center of the earth. It is moved from center of the earth to the surface of the earth. Then he is asking the change in potential energy. Change in potential energy formula, delta U is equals to potential on the surface minus potential on the center. So that will be equal to your minus capital G mass of earth into small m divided by radius of the earth. It is in minus. Then on the at the surface at the center 3 by 2 into capital G mass of your earth into m divided by radius of the earth. So obviously this value will come how much for me beta? This value will be equal to capital G mass of the earth into small m divided by 2 times of radius of the earth. Isn't it? So this will be your answer. Delta U will be equal to G into m into mass of the body divided by 2 times of radius. Or else I can even write this one as delta U is equals to mg into r divided by 2 times of radius of earth. Isn't it? Because small g is equals to how much for me? Capital G, capital M divided by r square. I'm using that relation. Okay. So what will be the change? It will be delta U is equals to mg into r divided by 2 times of your radius of earth. This is also radius of the earth. Or else delta U in terms of capital G, it is capital G mass of earth, mass of the object divided by 2 times of the radius of the earth. Am I clear?
Yes, sir.
Into that. चलो छोटा सा क्वेश्चन देख लो, ट्राई टू डू दिस वन. The change in gravitational potential energy. The change in gravitational potential energy when a body of mass m, when a body of mass m is raised to a height nr, n times of the radius of the earth, okay, above the surface of earth, above the surface of your earth. Chalo, try to do. Capital R will be the radius of the earth. Beta, I'll give the options for you, just check me the answer. N divided by n plus 1 into your mg into r. Second option is n divided by n minus 1 into mg into r. Third option is n times of mg into r. And fourth option is mg into r divided by n.
First option.
आ गया? He's asking just change beta. So change in potential energy formula, delta U is equals to your mg into h divided by, you can use this formula, 1 by h divided by r, shortcut formula. Delta U is equals to mg into h divided by 1 plus of your h by r. Am I clear? Then given in the problem, h is equals to how much? Given is h is equals to n times of the radius of the earth. So change in potential energy is right now mg into h is right now for me n into r divided by 1 plus h is your n into r divided by r. So this r will get cancelled. It will be equal to your n divided by 1 plus n into mg into capital R. This will be the answer. Am I clear?
Sir, and we didn't cancel.
Where, how do you cancel it? It is mg into nr divided by, it is 1 plus nr. Na? So here r is getting cancelled. It is 1 plus n and above is n. It is something like this, n divided by 1 plus n. ना कैसे करके करोगे? नहीं होगा ना?
Yes, sir.
Brilliant. अगर h की वैल्यू r होती तो आंसर क्या होता बताओ? खाली रफली बोल रहा हूँ. If h is equals to your radius of the earth, then change in potential energy will be equal to how much? Delta U is equals to mg into h. H value is your r divided by
mgr by 2
h value is r divided by r. यार कैंसिल हो जाता तो कितना आता? mg into r divided by 2 आ जाता सीधा. Isn't it? चलो इसका भी आंसर बोलो. इफ h is equals to, मान के चलो 3r होता तो पोटेंशियल एनर्जी कितना होता? चेंज इन पोटेंशियल एनर्जी, this is your mg into h value is right now for me 3r divided by 1 plus h value is equals to how much for me? 3 into r divided by r. So this r will get cancelled. So this value will be equal to how much for me? 3 mg into r divided by 4. So it is 3 by 4 times of your mg into r. आ गया?
Yes, sir.
Isn't it? So directly you can take that answers like that basically. Then अगर 2 times होता तो बेटा h is equals to 2 times of radius of earth, potential energy कितना होता? mg into 2r divided by 1 plus 2r divided by r. AR gets cancelled, so it is 2 mg into r divided by 3. Done?
Yes.
Sure. The next one. Escape velocity or escape speed, I can say. Okay. Escape velocity on the surface of planet is what, beta? The minimum velocity required to escape the body from the gravitational field. And to escape the body, its mechanical energy should be greater than or equal to 0, beta. Make sure of that body. To escape, you can write this one. To escape a body, its mechanical energy should be 0, should be equal to 0 or greater than 0 or greater than 0. This must be the condition. So what is an escape velocity? The minimum velocity required to escape the body from the gravitational field is called as of your escape velocity. And what is the mechanical energy, beta? Mechanical energy formula: total initial energy must be equal to total final energy. What is telling in the problem? In the concept is telling that total mechanical energy should be equal to what? 0. That means total initial energy must be equal to 0. Total initial energy means its initial kinetic energy plus its initial potential energy must be equal to its final kinetic energy plus its final potential energy. Finally, at infinity, the kinetic energy is 0, the potential energy is also 0. Kinetic energy on the surface of the earth is half into m into v square plus potential energy on the surface of the earth is minus capital G, mass of the earth, mass of the object divided by radius of the earth. Am I clear? And it is a potential energy minus. So this value will be equal to half into m into v square is equals to capital G, capital M, small m divided by r. So small m, independent of the mass of the object. So escape velocity formula will be v square is equals to 2g into m divided by r. So escape velocity is equals to how much? Under root of 2 capital G capital M divided by radius of the earth. This is the formula. Escape velocity in terms of mass of earth and radius of the earth. As small g is equals to capital G capital M divided by r square. So escape velocity will be equal to under root of 2g into your capital R. This will be the escape velocity. Clear? What is the value of escape velocity, beta? Anyone? 11.2 kilometer per second. So escape velocity, if a body has been projected with a speed 11.2 kilometer per second, then the body will escape to the infinity. So these are the standard formula. VE is equals to under root of 2gm divided by r, or VE is equals to under root of your 2g into your r part definition. Am I clear? And the value of this one is how much? 11.2 kilometer per second. Sure. Now can you tell me, VE is, can I say that, depends on what? Mass and size of what? Planet. VE is, I can say, independent of, escape velocity is independent of mass of object, but depends on mass and size of planet. Okay, so that is a way escape velocity on the Jupiter is more than that of your Earth, because Jupiter mass is more and radius is also more. So Jupiter is having more escape velocity compared to the Earth, and it is independent of what? Mass of the object. Next one, and very important point: if a body is projected with velocity, greater than escape velocity, okay, the interstellar speed is given by the interstellar speed is given by v is equals to, very important formula, under root of velocity which is given velocity square minus escape velocity square. That will give me the velocity of interstellar speed. Condition is what, beta? If the body is being projected with a velocity greater than your escape velocity, then the interstellar speed is given by v is equals to under root of your given velocity minus of your v square. Clear? Sure. Let me
Yes, sir.
show some application. Tell me the answer for this one. If a body is projected upwards, with velocity v is equals to k times of escape velocity, okay, where k is lesser than 1, okay, then maximum height attained from center of earth is, this is a very important application. But what is the condition? If a body is being projected upwards with a velocity, what is that velocity is given here? V is equals to k into v when k is lesser than 1. Okay, then what is asking right now here? The maximum height attained from the center of the earth will be equal to your how much? I hope you remember the formula. R dash will be equal to capital R divided by 1 minus of k square. Don't go for the derivation of this one right now. Directly remember that will give me the answer. Okay, whereas from the surface of the earth means it will be equal to how much for me? From surface of earth. From surface of the earth. That means h will be equal to small r minus capital R. So if I simplify this one, height will be equal to your capital R into k square divided by 1 minus k square. This will give me the answer directly. Thoda practice kar lo and remember this formula. It will always helpful for me, isn't it? And if I'm writing in terms of an escape velocity, this can also be written as of your h is equals to v square into r divided by escape velocity v square minus of your v square. This will be the height. Okay, very, very important, beta, isn't it? Maximum height reached from the center of the earth will be r dash is equals to your capital R divided by 1 minus k square. If it is asking from surface of the earth, then h will be equal to your r minus of your r. Am I clear? R means r dash only, beta, here. This is your r dash only. So if I'm simplifying that given condition, I'm getting h is equals to, h is equals to your capital R into k square divided by 1 minus k square. In terms of given velocity and escape velocity, h is equals to your v square into r divided by v square minus of your r. Clear? Sure. One more application. If a body is dropped from rest, from a height h, that is comparable to radius of earth, then what is the maximum velocity? Then maximum velocity with which it strikes the ground. V will be equal to escape velocity multiplied by h divided by r plus of your h. This all are having derivations, but I'm skipping the derivation because it will be a time consuming thing. Application is direct, and if you get a questions based upon this, whenever a body is being dropped from the rest and from a height of your h, and it is comparable to what? Radius of your earth, then maximum velocity with which it will be striking the ground is given by the formula v is equals to your under root of v is equals to escape velocity under root of h divided by R place of your H. And here we'll be asking one more conceptual question. I hope you already know it. Atmosphere on the surface of the Earth. Atmosphere on any planet, I can say. Any planet is possible only if RMS velocity, VRMS velocity is lesser than escape velocity of gas molecules. VRMS is nothing but what beta? RMS speed of the gas molecules. That is a condition you need to remember. Am I clear? Sure. एक बार देख लो जल्दी से. We'll try to do some numericals based on these given conditions.
हाथ भी डालिए ना ग्रैंड ट्वेल्व ऐसा कर
इंटरस्टेलर का फॉर्मूला याद है ना बेटा? If a body is projected with a velocity greater than the escape velocity, then v is equals to under root of v square given minus of your escape velocity. इस पे एक प्रॉब्लम कर लेते हैं. So we'll get an idea. चलो जल्दी से बता दो आंसर आप लोग. A particle is fired with a speed of 20 kilometer per hour. Okay. The speed with which it will move in interstellar space. In your interstellar space is the bracket escape velocity is 8 root 2 kilometer per hour. Okay, tell me the answer. Options are 16.5 kilometer per hour, 11.2 kilometer per hour, 10 kilometer per hour, and 8.8 kilometer per hour. चलो ट्राई करो जल्दी से. Particle is fired with a speed of how much? 20 kilometer per hour. The speed with which it will move in the interstellar space is, what is the speed with which it will be moving in the interstellar space? Given speed is how much better? V given is equals to 20 kilometer per hour. Escape velocity is 8 root 2 kilometer per hour. Isn't it? What is asking for me? Particle. Then what is the speed in interstellar? What is interstellar speed formula? Interstellar speed is given by the formula V is equals to under root of your V given square minus of your escape velocity. See how much I'm getting? So V square is equals to given velocity square minus of V square. So given is how much for me? 20. So it is your 20 whole square minus this is 8 root 2 whole square. So 20 whole square is how much better? 400. So it is 400 minus this is 8 into 8 at 16, 128. It will be your 128. 400 minus 128 is how much for me? 272 v square. So v is equals to under root of your 272. See approximately which option is matching this one.
16.5, sir.
16.5 something. 16.5 kilometer per hour. That will be the answer. Done. Okay. And tomorrow's session of your class, we'll try to complete with your satellites and orbital velocity. And then we'll go for the problems practice on the gravitation. Random questions and all the expected good questions. 50 questions collection किया हुआ है मैंने. That questions randomly from the gravitational force to remaining sections, we'll try to do it out. Okay. Graphical questions भी एक बार कर लेंगे अपन. So tomorrow we'll try to complete with your satellites, Kepler's laws and its applications. Kepler's laws application I'm not going in much deep because that will be time consuming. Direct application कर लेंगे थोड़े बहुत problems time वगैरह निकालने का. Then satellites, time period, frequencies वगैरह कर लेके then we'll directly go for your numericals based on this one. Today I'll try to send you the assignments on the gravitation. You also start doing them. And PYQs पूरा खत्म करो बेटा. I'll also send you some of the PYQs. So please try to complete it from your PYQ booklets. Okay. कल की क्लास में ऑर्बिटल वेलोसिटी करेंगे. एक बार पूरा कंप्लीट ग्रेविटेशन रिवाइज कर लेके आओ. ठीक है.
Yes, sir.
चलो बाय बेटा.
Okay, sir. Thank you.